On this video, I will show you on how to calculate t-test for correlated samples. What is t-test for correlated samples? The t-test for correlated samples is another parametric test applied to one group of samples. It can be used in the evaluation of a certain program or a treatment. Since this is another parametric test, conditions must be met like the data should be normally distributed. When do we use t-test for correlated samples? The t-test for correlated samples is applied when the mean before and the mean after are being compared. The pre-test is measured, the treatment of the intervention is applied, and then the post-test is likewise measured. The two means are compared. Why do we use t-test for correlated samples? The t-test for correlated samples is used to find out if a difference exists between the before and the after means. If there is a difference in favor of the post-test, then the treatment or intervention is effective. However, if there is no significant difference, then the treatment is not effective. This is also an appropriate test for the evaluation of government programs. This is used in an experimental design to test the effectiveness of a certain technique or method or program that had been developed. How do we use the t-test for correlated samples? We use the formula T is equal to d bar divided by the square root of the summation of d squared minus the quantity of the summation of d squared divided by 2 all over n times the quantity n minus 1, where d bar is the mean difference between the pre-test and the post-test. Summation of d squared is the sum of the squares of the difference between the pre-test and the post-test. Summation of d is the summation of the difference between the pre-test and the post-test. And n is the sample size. Applying now our formula, let us have an example. An experimental study was conducted on the effect of program materials in English on the performance of 20 selected college students. Before the program was implemented, the pre-test was administered, and after 5 months, the same instrument was used to get the post-test result. The following is the result of the experiment. So we have here the pre-test and the post-test result. Solving by stepwise method. First is to state the problem. On our example, the problem is there a significant difference between the student's pre-test and the post-test score on the use of program materials in English? Next will be the hypothesis. For the null hypothesis, there is no significant difference between the pre-test and the post-test. For the alternative hypothesis, the post-test result is higher than the pre-test result. Notice that on our alternative hypothesis, this is a one-tailed test. It is because this is a directional test. From the word higher, there is a direction. Next will be the level of significance. First will be the alpha. Alpha is equal to 0.05. On our example, alpha is not given or stated. So, we will be using alpha at 0.05. So, if the alpha is not given on any problem, use alpha at 0.05. Next is the degree of freedom. On t-test for correlated sample, df is given by n minus 1. So that will be 20 minus 1, which is 19. Next is the t-tabular value or the critical value. In here, we'll be needing the t-table. So this is our t-table. Since the test is a one-tailed test, we'll be referring the alpha from here. So let us find for the alpha 0.05. So it is located here. And then for our degree of freedom, find for 19. So 19 is located here. And then find for the intersection of the two. So the intersection of the two is 1.729. So that is the t-tabular value, which is 1.729. So later on, the t-tabular value will be having its sign. It will depend on the t-computed value. It is because this is a one-tailed test. Next will be the statistics. We'll be solving it using t-test for correlated samples. So we have here the data a while back. So we have the pre-test and the post-test. For the pre-test will be our x sub 1 and our post-test will be x sub 2. So we have here d, which is the difference between the pre-test and the post-test. And we also have d squared, which is the square of the difference between the pre-test and the post-test. So on d, we have 20 minus 25, which is equal to negative 5. Squaring negative 5 now is equal to 25. Then 30 minus 35 is negative 5. Negative 5 squared is 25. Then 10 minus 25 is negative 15. The negative 15 squared is 225. So continue doing the same process until we arrive at the last data. Then we have the summation of d. Summation of d is the sum of all the data under d. So the summation of d is equal to negative 81. Then we also have the summation of d squared. So summation of d squared is the sum of all data under d squared. Since we already have the following values, then we are now ready to solve for the t-test using our formula. So we have t is equal to the mean of the difference of the pre-test and the post-test. So that will be d bar, which is equal to, so let us get the mean. So the summation of d divided by n. So that will be equal to summation of d, which is negative 81 divided by n, which is 20. So for our d bar, that is equal to negative 4.05. Then we are now ready to substitute all the values into our formula. So that will be equal to for our d bar, that will be negative 4.05. Then we have the square root of, so we have the summation of d squared, which is 947 minus, so we have the summation of d, which is negative 81, then is squared divided by n, which is 20. Then we have n, which is 20 times 20 minus 1. Then evaluate it further. So that will be equal to negative 4.05. Then we have 947. So negative 81 is squared divided by 20 is equal to negative 328.05. Then divided by 20 times 19 is equal to 380. Then evaluate further. So negative 4.05 square root of, so 947 minus 328.05 is equal to 618.95 divided by 380. Then simplify it further. So 4.05, then we have 618.95 divided by 380 is equal to 1.6288. Then that is now equal to negative 3.17. So the t computed value is negative 3.17. Then let us go back with the t tabular value a while back, which is 1.729. Since the t computed value is negative, therefore the t tabular value will be negative 1.729. It is because this is a one-tailed test. There is only one tail. Then it's now time for us to have the decision rule. So if the t computed value is greater than or beyond the critical value, this confirms HO or the null hypothesis. So for us to find out if the t computed value goes beyond the t tabular value, let us illustrate it. So for example, since that is a negative, so the mean will be here, and then the t tabular value is negative 1.729. Let's just say negative 1.729 is located here. Then let us locate negative 3.17. So most probably negative 3.17 will fall beyond negative 1.729. Since it goes beyond the tabular value. Therefore, we will going to disconfirm or reject our null hypothesis. Then it's now time for us to make our conclusion. The t-computed value of negative 3.17 is beyond the t-critical value or the t-tabular value of negative 1.73 at 0.05 level of significance with 19 degrees of freedom. The null hypothesis is therefore disconfirmed or rejected in favor of the research hypothesis. This means that the post-test result is higher than the pre-test result. It implies that the use of the program materials in English is effective. So that is the t-test for correlated samples.